the topic for today is about our life as software engineers, and a question that many are asking: will we transform from software engineers to prompt engineers, or will we do something in between, or what's the future for us? And Gabi already introduced us a little bit for whom doesn't know us. What I want to say is that we are not experts in AI, we are not experts in machine learning. Yeah? We are software engineers, and we share with you our experience and our thoughts about how it influences our life. We see AI everywhere. We talked already about it. You hear about it everywhere. Is it a threat or is it an opportunity for us? And that's a question I think most of you from the room have or should have. And we saw already it can do a lot of things. It can help us, it can generate code, it can do testing, deployments, many things. But we will look to answer some questions during our session. Does it really work so well today? I think that's important to know. Then, are we really so much more productive? Because there's a big hype. Yeah, we use AI tools. Everything is going to be very fast. We will solve the same problem 10 times faster. We'll spend 5 minutes, code will be generated. We can do much more. But is it really like that? Let's see. And in the end, will it replace us? Will we have to do something else in the near future or in some years from now? We don't know yet. And we wanted to start with a little bit of something for you. Please log in using that QR code and try to answer. So give us an answer for these questions. We want to see how you feel about it. I'm aware of the position I am on this, so.
Okay. So let's see. Excellent. Oh, yeah, the responses are still coming, so give it some.
Yeah, we'll wait. We'll spend a few minutes.
Okay.
Don't
we
be shy,
have a
don't be
few
shy,
concerned
20, 30.
people over there. Decreasing, luckily. Okay. I would say pretty much settled.
No, we have colleagues that are just scanning. Let's see.
People are still voting. Okay.
Important opinion, Emma, important. Do we have 100 people in the room? Probably not. Yeah, okay, so Shelby.
Thank you. Nice. So let's see if our talk can change the feeling, and afterwards you'll still feel the same. I see the number of concerned people in the audience is quite limited, which is glad to see. But before jumping into looking how software engineering will change, let's reflect a bit on what software engineering is. What are we doing daily? So, of course, our raison d'etre is to build an algorithm. Everything is an algorithm. An API, a query, the most basic stuff is an algorithm. This is the core of what we do. And what is an algorithm is just taking some data X and turning into some data Y, using machines, of course. Now, this might seem trivial, but it's really not, because we spent years of learning programming languages, learning engineering best practices, understanding the business domain, understanding how machines operate at the low level. And we put into this endeavor all our hopes and dreams and our personal time to learn and to grow, and you know the drill. But always, so this is the core that what we do, but there are two very distinct ways in which we can approach this problem, turning X into Y. And let's try to use a metaphor and to express the difference, the core difference between the two approaches. And let's go back 2,000 years into ancient Greece. How would the Greeks solve the hypotenuse dilemma? You know they have to build a great temple or building, and they need their corner to be squared. And how are they making sure their corner is square? Well, Pythagoras solved the puzzle, and it showed us that there is an equality, a mathematical equality, that we need to solve. And if these numbers satisfy the relation, then we can be certain that the building will hold, you know, the corner is right. And this might seem like a trivial job, because in Java, you do it like that. I mean, it's one line of code, you know. However, how many of you actually, do you think, everybody I think knows how to write this in any language. But do you really know how to compute the hypotenuse? Because that line of code is written by someone else. This is just 1/4 of the square root algorithm implemented in Java, in this case. So I don't know how to do that. I mean, I'm writing Java for almost 12 years, and this is totally new for me. What I'm trying to say is that everything we build in this approach, in the mathematical, structure, scientific way over the years, is built on the shoulders of giants, on a lot of mathematical knowledge and tools, preciseness, and deterministic behavior that we have in our code. And this is the approach that got us up until this point in the entire software industry. This is how it started, and this is how it's going. But there is a different approach. This is not the first one. There is a more heuristic approach. You know that Egyptians built structures, and they had square corners because the pyramids are still standing. How did they do it? Because they didn't know mathematics. They didn't know how to measure a square angle. They used heuristics. They had a lot of data. That they had a rope that you see on the screen, and heuristically, they knew that certain lengths will always yield a square a square angle. So they had this pair of numbers. Somebody collected heuristically in the world this data set. And if you want a new pyramid, I want a bigger one that was never been built, how can I make sure I can build it safely and reliably? Well, you had to go to an Egyptian data scientist and say, I know these pyramids are safe. This is the numbers that I collected. Build me a new one. So this means, given A and B, predict me the C, the hypotenuse. And you can see the difference between the two approaches. There is no mathematics behind. There is no deep understanding. There is no deterministic behind it. But we can still do our job. I think you kind of get the analogy that we are getting back to the old Egyptian way in using data to guide software, in a way, in a sense. But now I would like to take you back into maybe the current day and era and talk about software as it is right now.
Yeah, we have to play a little bit this dance of passing the remote around, so it's not a dance. The dance is tonight, yes. What we see today, and also in the presentation so far, is that we are looking at basically three worlds nowadays. And these three worlds are, in our perspective, the world of classical software engineering, what we did so far, and what most of us are doing. And then this is already here it's the AI-assisted software engineering, where we get support. And last but not least, it's the world of AI-driven software engineering. A little bit of what Gabi said in the morning, what will come maybe in a few years. Let's see how fast. And I will talk a little bit about each of them. First of all, traditional software engineering. We all should know it by now. So if we are in this room, this is something that we do. So we know how to do this. This is the status quo. What do we do in this world? What's our work? What do we spend our time on? So we write code by giving computers precise instructions. Yeah? So that's our main activity. We write the code. And then this makes us what? Some say, yeah, or business problem solvers and so on. Yeah, but 90% or 80% of our time, when we are not in calls, meetings, and so on, or drinking coffee, we are writing code. Yeah, so a lot of us, we spend a lot of time typing, and that's a reality. Some type faster, some, like me, after many years of programming, I still type with only a few fingers, so I don't know how to type. It's okay. But that's our focus. We craft the code, so we produce code, a lot of it, which solves problems, of course, but we produce the code. What do we learn in this world? We learn programming languages. So how many of you learn more than one programming language and know more than one? Okay, everyone else knows one programming language? Or you're shy, you say, we don't know because you're not experts in the language. But I'm pretty sure everyone saw at least code written in more than one language. Yeah? So that's. Then we spend a lot of time studying libraries and frameworks and getting acquainted with those and reading their documentation and seeing how they change over time. So a lot of the time is spent also on this. And we learn algorithms because they are important. We search a lot for examples, for documentation, and yeah, for many, one of our best friends is Stack Overflow, yeah? Or was Stack Overflow. I think, is there anyone in the room that didn't use Stack Overflow ever? I want to see who's really, no.
We'll kick him out.
No. But you do software development.
Oh.
Okay, we'll chat about that. Good. But usually we at least once saw or went to Stack Overflow to see what others did in order to solve a problem. Defining attributes of this world. This world is deterministic. Yeah? So we know that if we write this code, it produces this output most of the time, unless it has bugs. But most of the time, what it says it does, it happens. Then it's pretty well documented. So all these APIs, all these frameworks, there are all these discussion groups and forums and Stack Overflow, and you can ask colleagues. And there's so much information about this world that we usually find what we look for. Yeah? Unless you use some obscure API that no one used and so on, and you have to really try it out or read the code. But even then, you read the code, it's fine. You can understand what it does, you can handle it. It's pretty reliable. The code written in this way works so far for tens of years already. Yeah? So we do programming for 50, 60 years, something like that, or maybe more. And it works. Faster, slower, but it works. We know how it works. It's testable. I know we have people from colleagues that are doing testing also in the room. So we know how to test this. We know how to look for problems. We have all these things put together. It's safe. This code, we know what to do in order to make it safe. And there are tools that help us to do that. And there are companies that audit code and audit systems and do security testing, penetration testing, all these kind of things. So again, known. So this makes us comfortable, I would say, as software engineers. It's the world we know. We are comfortable when we know things. And if not, we learn quite quickly, not a problem. But is this enough nowadays? We saw there's a lot of data being produced. There are all these AI tools coming around. People launch robots that code, solve. We saw the workspace from Microsoft, from GitHub before, doing specifications and everything. Yeah? So is it enough to just write code in the traditional way? And our opinion, and from what we saw in the poll, many of you start to feel that way, is that it's no longer enough. So these tools, this AI-assisted software engineering is here today. For some already for a few years. So some of us already use these tools for some time. I use them, a little bit of some years. This impacts how we work. So in this world, we use these AI assistants, which become like our virtual body. Yeah, I think in Accesa we have bodies in. So in our work, you have your colleagues, but you have also mentors, and I'm not so sure, but I think yes, that's how we do it. So AI becomes our virtual body in this world. And there are many smart tools that can do these things. There are many smart tools that we can use to ask for information, to show us how to write some piece of code, how to write an algorithm, and so on. And also very important, we interact with those tools in human language. So we no longer write code in order to talk to these tools. These tools are made in order to interact with them like we interact with our colleagues. That's why we say it's a virtual body. What we also do a lot is we learn more, so we shift our focus to learning the business more. What we really need to do, because we spend less time, I would say, in how we write the code. So we learn more about the business, about the problems we want to solve, and we focus here on this adding value. So you will hear everywhere these days. Focus on value-added work. Don't focus on boilerplate. This, rather sooner than later, and hopefully increases productivity in our work, which means we produce more in less time. Not the exponential growth that there was a slide at the beginning, if you remember. I put that picture like that intentionally. Most likely it's not like that. So the more complex the system is, it's not going to be faster, but it's going to be probably like a plateau. Because when the problem is simple, you have a quick start. It's amazing what Copilot can do to generate code quickly, but we'll see a little bit how it can do when you have to use large code bases and so on. But in general, productivity increases. I can say that from experience. You really are faster, much faster. I don't like typing again, so that saves me a lot of time. Shelby, then I think we have some examples of how it really
Yes, I'm also a user of large language models. I think as most of you voted, I sometimes go to the Copilot or to the IDE if possible and try to ease my way into software engineering. And I had time to pick just one illustrative example of why me personally, I'm not at all scared about losing my job because of LLMs, not yet, at least. So let's see what the example is about. And I think it's illustrative because I've seen it a lot, so it's more like a pattern than an example. For a simple use case, let's suppose you want, and this is a concrete use case, let's suppose you want to convert a public key. Something that is related to cryptography, that the more technical ones from you would know. And you ask a model, please, I need from a key, from a raw version, give me a base64 encoded one, the keys that you saw in the browser, those long strings. And the model will simply give you a base64 encoded string, which of course, is not what we wanted. We have a public, but how do we know what we want? So we need to know cryptography terms, like what are the standards of encoding a public key, what algorithm, what curves, what types of public keys you know. And if you give the model a lot of these insights, for instance, I have the concatenated X values, I'm talking about an elliptic curve cryptography, and so on, then yes, it gets better, it gets better. It gives you some meaningful code. But over there, it uses an X509 public key. Do you know that standard? Some of you, no, nobody? Okay, yes, the DevOps guys will know that this is the public key that is used to secure our internet. When you log into a browser, the certificate is in this format. And why the model gives us this format? Because this is the most widely used across the internet. But is it what we asked? Definitely no. Do we know that it is not what we asked? Well, you need to know a lot of cybersecurity to know that it's not what you need. So given that assumptions, I'm pretty safe because getting all the knowledge of cryptography to use a model that can help you in your job, if you have that knowledge, you're already in a good place. But after giving it the specific knowledge that I have a specific algorithm, a specific curve with these parameters, with this bit size and all that, it can indeed generate usable code that can solve the cryptography problem for us. Yeah, what should we take from this? Is that we can use these models, but we need to have a lot of knowledge to use them properly and to solve complex problems, not just simple snippets of code. So this will be your job to make sure that you have that knowledge and that business understanding. And this is a trap. The trap that maybe some managers or some product engineers will say, okay, now we have AIs, why don't you quickly generate me the product, the code? Well, it's a trap because we are stopped, or the progress is stopped by our own lack of knowledge about the business and the technical stuff, like you saw, cryptography, security. And what I noticed in using as a user of this system is, in general, LLMs behave like this. When things are out there in the world and are true and are correct, it can say that they are correct. So if I want to know more about a specific framework or like a standard, it gives me correct information. This makes this model useful. It rarely says that something which is in the world, it's not there, it's not found, or it's incorrect, because it's trained on a lot of data. So it kind of knows about all the programming language, all the standards and whatnot. Also, it's not trained, they try not to train them with false information so that it will give you false answers by default. The problem is here. It gives you a lot of false positives. So what this means, if you don't know what is true about the world, how IT industry works in general, it will give you those false positives. A good example, if you use Spring Data, I assume, or the Java people. I asked a model, a GPT-4, some questions about Spring Data to generate me some methods, some queries that they do not exist. But it tries to comply with the user. So trying to be compliant, it gives you these false positives. So you need a lot of knowledge to know what is true from what is false. Also, the second point that I want to talk about, the second trap, is that it's easy to integrate the code snippets, all that is produced. I can assure you it is not easy to integrate. And one reason is that, at least currently, the LLM models are trained on very poorly written code. It's not corporate code. It's not safe code. It's the most basic Stack Overflow code, which in your financial industry or safety critical or professional development, it's definitely not good enough. In the future, we hope that it will be trained on enterprise code, and we will see how this will evolve. But right now, you need to be careful that it's definitely not built in a safe way. Cristi, what do you want to share?
Yeah, I also have some traps on the list. So Shelby already mentioned a little bit that it can generate false positives. So sometimes it tends to hallucinate. That's the name of this. It produces things that seem correct, and but they are not something that you should use. Yeah. Then one other thing that I saw also for myself after 2 years of using Copilot is that you tend to get this Copilot syndrome. It's maybe not in the books for the health and safety colleagues, but it will be probably. Yeah? Copilot syndrome means that I got used to press enter and wait. So the brain adapts to this way of working quite quickly. You wait for the sugar to come. So it's like you're a small, like the dog. Raises the hand, yeah, raises the front leg. So that's something that it's definitely there, and it's quite talked on the internet. So we have to keep thinking, not just wait for the cookie to come all the time. Press enter, wait. No, sometimes we have to do something. And another one is we can quickly become vendor captive. Yeah, so there are a lot of providers, let's say vendors on the internet, on the world, that are trying to produce these tools, succeeding, some of them. And of course, first they were free, and in the era of training, you could use all these things for free and so on. Now they started to cost money. And we can quickly observe they start to cost more and more money. And we get into everyone loves this subscription model in the financial world. So you don't get a license and it's yours forever. No, you pay monthly. The moment you don't pay, you don't have it. And the payment can increase. Yeah, someone say, from this year, 20% more. What can you do? Pay. That's it. So it's easy to get captive. It's a business, good business for many. Of course, there are many benefits, yeah, but there are some traps also. And this is the AI-assisted world. Yeah? This is what we start doing today, and we encourage you to do it. Yeah? So Gabi said that there will be also more available, yeah? Copilot. Start using it if you don't use today. Yeah? It's really helping on many tasks. The two answers that we saw, they are pretty much what happens. But there's also the world that we're seeing, and it starts to be presented to us. And in this world, we see software that generates software automatically without people intervention, or with minimum people intervention. We see changes. Yeah? And Shelby, you have some insights here.
Yes, let's talk a bit about how we will be delivering software in the future, because we have already seen a shift, a trend in the POCs that are requested from our customers, in the business decisions that we make. We are going back into the Egyptian way of thinking, data-driven problem solving. And we have to get used to it, unfortunately. And why? I was thinking, why are we forced into working like that? So one reason is that the test complexity and the stakeholder expectations increased. Remember, a while ago, our requests used to be from the stakeholders, display customer orders sorted by date and stuff like that. This was the common use case. But nowadays, more and more customers try to ask us, but what is the optimal discount that will maximize my profit? Which is a problem we cannot approach deterministically, only in a data-driven way. What does this mean for the software that we write? Also, it's assisted by the democratization of machine learning. We started with AutoML available in all cloud platforms, and even a software developer like me with no scientific knowledge could build machine learning algorithms. And now with the LLM, it exploded because classification and language interpretation job and semantic analysis became trivial. So we expect to see this increase in the data-driven problem solving, that all the developers will be impacted. Christy, do you see any other data?
Yeah, I also see there's this big pressure on software engineering, again, make it open to the world. So don't have software engineers solve software problems or engineering problems, but everyone can solve software engineering problems. All these no-code approach tools, it kind of feels like we've been there some years ago. I mean, I saw the drag and drop programming some time ago. It looked fine, but what was behind? Good luck with that, maintaining it when it grows bigger. It worked, but how fast and when your data was more and more, interesting. And today we see also this pressure. So this approach to make it everyone will write code, everyone will be an engineer, maybe not so. So let's see.
So thank you for your take on that. Now, let's see how will our application supposedly look like in the near future. We're talking about the near future. When we have a task that cannot be solved deterministically, mathematically, we have to involve some sort of a network, which is maybe a large language model, maybe something we train ourselves, and we use it from our own written code just to solve this specific question, to classify some data, to give some insights, to prepare some key takeaways. And then we take the output and we process it ourselves. This is related to previous presentation. This is also the RAG, it's one idea. And we will have to be prepared to handle the uncertainties of introducing such models and such delays and all that comes with it when we introduce a model into our deterministic programs. But also, more and more, we get into this type of architecture, which is suitable for certain applications, where the decision itself is guided by the LLM, where the LLM, usually more of them, are deciding what needs to be done next, what needs to be programmed. In this case, what remains for us to do is that little box in the middle, and this will be one agentic workflow pattern where all our traditional software development will happen downstairs when we teach the model to access some sort of external functions, maybe to read data from an old database that it doesn't know yet. So, yeah, you might be a bit pessimistic about this world, but I think there is a great opportunity also for us. Now I will pass for the conclusion to Christy. Back to Christy.
So, yeah, we try to show a little bit this world. So where we were, where we should be today, maybe, and what might come next. And let's draw some conclusions from here, from all this talk. We think that engineering practices are becoming more and more important. Yeah. So we need to know how to use all these things, how to integrate them, how to write code in a, let's say, a good way, yeah, or the correct way. So we need to have clear and good practices. Cowboy programming, not so much, because many things are becoming even more important. Quality of this code, how safe it is, security, IP. I think we didn't touch a lot about IP, but from intellectual property point of view, what happens when you use code that's provided by the machine, or when you provide your code to the machine or customer code to the machine? Everyone says, no, this code is not used. The models are stateless. They don't learn from your code. They don't save your code. Yeah, but there are many tools and APIs in front of the models for your IDE to interact with. Is it really that your code and your prompt is not being logged? It's a good question. So all these things from engineering, we need to learn them, keep learning them, and they are more and more important. Then code crafting, so the part of typing the code and just writing code, that we think it becomes less important in these days. So of course, we will spend less time writing the code itself, and we will spend less time. Our focus will not be on producing the code. Yeah, it's going to be on writing the meaningful code, making sure it's meaningful, automate whatever can be automated, so generate persistence code, tests, algorithms that do things in your code. These things generate as much as possible, and the tools do a good job already, many of them, if you give them enough information, of course, and if the context is known. Another thing is that, we like it or not, we suggest that we have to learn to work with these AI tools. It's no longer a question of should we, it's yes, we should. Because it was said already before, if we're not using those tools, someone else will, and they will be faster, cheaper. So then the jobs will be gone. Not to the tool, but to the person using the tool efficiently. Yeah? But I think that's true in technology for years. So it's, again, not something new for us. Yeah, it's the same with programming language. It's the same with the architectures that we saw in the morning. It's the same with networking. If you stay in place, someone else will overtake you. That's the world we live in. That's the world of technology. Yeah? This is the same thing. If we just don't do anything, someone else will do it. So we have to do something here. Another skill that I think is very important in this world is to learn to review code. Again, best practices from engineering is important, and you will spend more and more time reading code and reviewing the code produced by these tools. Yeah. Not many are doing code reviews, or I don't know how many of you are doing code reviews day by day, but welcome to the world where you will have to do this all the time. Yeah. Because again, it was also said before, this code is given to you, produced for you, but it's your responsibility. Our responsibility. Yeah, it's not like it goes in production, then someone buys a Chrysler, it was, for $1, and or someone gets a loan from the bank because we are in the banking world, and someone gets a loan from the bank for negative interest. Maybe the bank pays you some money to give you money. And then you say, it was AI that generated that code. I just put it in production. I don't know. I don't think we can do that. Yeah. So in my opinion, we're still very much responsible for the code we produce. And yeah, to leave you with this a little bit, I think we should be also a little bit back to theory. So we go to school, we go to the university, we learn a lot of theory. Sometimes we say, it's boring. It's not going to help in the future. I just want to go there and write code. I learned some languages. I do some plural site. There are so many platforms where you can learn the programming language, so many resources. Yeah. And you program not necessarily knowing the theory and the fundamentals behind in all this technological world. Yeah? So I think it's very important to go a little bit back and to understand also what's behind that and what do we want to achieve with this, because it's going to be more and more important. And yeah, this is what we had to say. Hopefully, it helps you in knowing that, yeah, jobs will not be lost, in my opinion, but we have to do something also. Thank you.
Thank you. Thank you.